Today we're going to talk about two kinds of numbers. We're going to talk about atomic number and we're going to talk about mass number. So let's start with atomic number. The atomic number is the number of protons that an atom has in its nucleus. And hopefully you found out when you did your lab a couple of days ago that every time you dumped another proton into the nucleus of the atom, the name of the element actually changed. The number of protons is like a fingerprint for the atom, and it helps you know exactly which atom you're talking about. The periodic table, and if you have your book, hopefully you have your book with you because I told you to have it, you need to find your periodic table of the elements. There is a periodic table on pages 80 and 81. I think there's probably also a periodic table on your inside back cover. I'm not entirely sure because I don't have I don't have the student edition, I only have the teacher's edition. But what you're looking for is 2 pages that look like this in your book. So like I said, it may be on the inside back cover, it might be on the inside front cover. If not, I know it's on pages 80 and 81, so you want to make sure that you can see that. If you are using an electronic copy of the textbook, you are going to want to print out a copy of the periodic table, whether you print this out, whether you download another one from online someplace and print it out, but you will need to have a copy in front of you as you're doing a lot of the homework assignments for the rest of this chapter. Okay, so what is this big table? Well, each one of these boxes represents a different element, a different kind of atom. And each element has a specific number of protons in its nucleus. Now, the number of electrons can change, the number of neutrons can change, but the number of protons tells you exactly which kind of atom you have. And so, for example, if I look up here at the top left corner, at hydrogen, hydrogen has up in the upper left-hand corner of the box, you see a number 1. That is the atomic number, and that tells you that hydrogen always has 1 proton in its nucleus. Now, if I go straight across the table and I look over here at this side, you see an He, which stands for helium, and you see a number 2 in the upper left corner of that box. And that tells you that helium always has 2 protons in its nucleus. Now, as I go from left to right and I go down the table, just like you would read, the numbers are going to get bigger. So Li, lithium, has a 3. Be, which is beryllium, that has a 4. If I look over here, boron is 5, carbon is 6, nitrogen is 7, oxygen is 8, fluorine is 9, neon is 10. And so then if I come back here, I have 11, 12, and you can see that as you go down the table, those numbers keep getting bigger and bigger and bigger. So each time I add a proton, I'm going to change to a different element on the table. Now, one thing that you may be wondering is that a lot of the symbols have 1 letter and sometimes they have 2 letters. Well, part of that's because there's a whole lot more elements than we have letters, obviously, so we'd have to have more than 26. H is hydrogen and He is helium. And then I have something like, if you look at this one here, which is the 3rd one down on the left-hand side, Na, it says that's sodium. Well, that doesn't seem to make any sense. Why wouldn't sodium have an S in it? Well, sometimes in place of using abbreviations from the English name for the element, sometimes we're going to use abbreviations from the Latin name for the element. Like, for example, this one here, Fe, which is iron, the Latin name for iron is ferrous or ferric, and so they use the Fe from the Latin name for that abbreviation. So while a lot of them are going to seem pretty intuitive, you know, O is for oxygen and S is for sulfur and N is for nitrogen, there are some that don't seem to make any sense, and that's why. It's because we've had to use the Latin name to come up with the abbreviation for that. Okay. If you're going to, the other thing I wanted to mention is if you're going to write a 2-letter abbreviation, you'll notice on the table that the first letter is always a capital letter and the second letter is always a lowercase letter. So you want to make sure that you're using capital letters and lowercase letters. I know there are some people that seem like they write in all capital letters all the time. And when you're writing symbols for elements, that's not okay. You want to make sure your first letter is a capital and the second letter is lowercase for those elements where you need a 2-letter symbol. Okay, so that is atomic number, and the atomic number will tell us the identity of the element, of the identity of the atom that we're talking about. And the other number is the mass number. Now, what we talked about yesterday is that the number of protons plus the number of neutrons is going to give us the mass of the atom. The electrons have a little bit of mass, but it's so small in comparison that we don't worry about it. And so we look at the number of protons and the number of neutrons. And so if I add that together, that gives me the mass number. So let's take hydrogen as an example. I know that hydrogen from the periodic table, because the number up in the upper left-hand corner was a 1, that means that hydrogen is always going to have 1 proton. That will not change, okay? Sometimes hydrogen doesn't have any neutrons at all. It just doesn't have any. Sometimes an atom of hydrogen, again, always has 1 proton. Sometimes it has 1 neutron. Sometimes I will have an atom of hydrogen that has 1 proton, and sometimes it'll have 2 neutrons in it. So the number of neutrons can vary, but the number of protons will always stay the same as long as it's hydrogen. So if I'm going to name these, I name these by what the mass number is. So 1 proton and 0 neutrons, 1 plus 0 is 1. So that means that the name for this particular atom would be hydrogen. Oops, I didn't spell that very well, did I? Hydrogen 1. If my atom of hydrogen has 1 proton and 1 neutron, 1 plus 1 is 2. So the name of this atom would be hydrogen 2, to tell me that the mass number is 2. If it has 1 proton and 2 neutrons, 1 plus 2 is 3. So the name of this is going to be hydrogen 3. They're all hydrogen because they all have 1 proton in them, but the mass numbers are different because they have differing numbers of neutrons. And so these 3 different kinds of atoms are called isotopes, because iso means same, and so they're isotopes because they have the same number of protons, but they do have differing numbers of neutrons. Okay, so this is the term isotope, and it talks about atoms of the same element that have different mass numbers, different numbers of protons and neutrons. Same number of protons, but the sum of the protons and neutrons is going to be different. Okay, so what we're going to do now is we're actually going to practice. If I have different information, can I figure out other pieces of information from what I have? So I told you that you needed to have the Day 4 practice worksheet available, and so if you'll get that and have that in front of you along with the pencil, we'll go through the first several examples so you can see exactly how to make this work. In the first line, the only thing I gave you was that the name of the element is helium-4, okay? And we're going to fill in all the rest of this information. We're going to fill in the symbol, the atomic number, the number of protons, number of neutrons, number of electrons, and the mass number, and all we have to know is this piece right here. So again, you're going to need your periodic table, and helium is over here, and you can see that the name of the element is written in there. So helium is over here, and you can see that the abbreviation for helium is He. And so I can write the symbol in here as He. What's the atomic number for helium? Well, again, if you look in the upper left-hand corner of that box, you can see that the atomic number for helium is 2. The atomic number is always the same, and the atomic number always tells me how many protons are in the atom. So if the atomic number is 2, that means the number of protons is also 2. Now up here, you notice that I added the number of protons and neutrons together to get the number that comes after the name. And so if this says helium-4, that 4 means that that must be the mass number. So the number that comes after the name is always the same as the mass number, okay? The protons plus the neutrons equal the mass number. So 2 plus what is going to give me 4? 2, right? So if I have 2 neutrons, 2 plus 2 makes 4. Now what about the number of electrons? Well, for right now, we are going to assume that the number of electrons is going to be the same as the protons, because right now we're just going to be dealing with neutral atoms. Later on, a little bit later in the chapter, we're going to talk about atoms that have a charge on them where they're not the same. But for right now, the number of protons and the number of electrons, we're going to say that they're the same because this does not have a charge on it. All right, so that gets our entire first row filled in. That wasn't so bad, was it? Let's look at the second row now. In the second row, I told you that the symbol was B and that it has 6 neutrons in it. Well, if you look at your periodic table, the B is located right here, that first purple box up there. So if you look at the B, what is the name of that element? You see it on there? It should say boron, B-O-R-O-N. And I'm going to have a number after it in a minute. We'll get to that. What is the atomic number for boron? Well, if you look in the upper left-hand corner of the box, you should see a number. What do you see? You should see a 5. So the atomic number is 5. How many protons does that mean it has? Well, remember, the atomic number and the number of protons is always the same. So if the atomic number is 5, then it has 5 protons. And I also said that for right now, we're going to assume that our atoms are neutral. So if it has 5 protons, it's also going to have 5 electrons. Now, I told you how many neutrons it has. And so if it has 6 neutrons and 5 protons, 5 plus 6 makes 11 for the mass number. And the mass number is what goes on the end of the name, right there, okay? So there's our second row filled in. Now, what information did I give you for the third row? Well, in the third row, I told you the atomic number is 9 and the mass number is 19. Okay, well, the only way I can figure out what element this is, again, to go to the periodic table. And while I've got this thought in my head, when you're taking a test, you're always going to be allowed to use a periodic table. There's no way you can do these problems if you don't have a periodic table in front of you. So periodic table is just as important to taking your test as a pencil is. So make sure that you have your periodic table a week or so from now when you're getting ready to take a test. All right, so atomic number is 9. If you remember, we said that the atomic number increases as I go from left to right and as I go down the table. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you look right here on this box with the F, you should see a 9 up in the upper left-hand corner. That's the atomic number. So if the atomic number is 9, we have an element called fluorine. The symbol for that is an F, and this is spelled F-L-U-O-R-I-N-E. People tend to try to spell it with an O-U, but that's flour. That's what you use in the kitchen. This is not fluorine, it's fluorine, and it's U-O. And again, we're going to have a number after that in a second. If I know the atomic number is 9, what does that mean the number of protons is? Yep, it's also 9. These are neutral atoms, so if I have 9 protons, how many electrons do I have? Yep, I have 9. Now, I have to figure out the number of neutrons, but I have the mass number, and we said that the protons plus the neutrons make the mass number, so 9 plus what is going to give me 19? So 19 minus 9, you can subtract them, do it backwards, and so I'm going to have a 10 right there, because 9 plus 10 makes 19. And I also know that the mass number is what comes over here on the end of the name, fluorine 19. Okay, so we'll do one more example. I know that the number of protons is 11 and the number of neutrons is 12. So if the number of protons is 11, what do I know? Well, I know what the atomic number is, right? So if I know that the atomic number is 11, I can now go to the periodic table and I can find the number 11 on the periodic table. We were just at fluorine, which is 9, neon's 10, and then down here is 11, and that's Na, which is sodium. So I'm going to have an Na right here, and the name of it is sodium. I'm going to need a number after it, so you want to make sure you come back and put that on there. Because I'm dealing with neutral atoms, number of protons and the number of electrons will be the same. So if I have 11 protons, I'm also going to have 11 electrons for right now. And then how did we get the mass number? Do you remember? You're going to take the protons plus the neutrons together. And so if I have 11 plus 12, that makes 23. And so this 23 is what's going to go on the end of my name over here, sodium 23. Okay? So you can see that depending on what information I give you in this chart, by using the periodic table and a little subtraction, you can find out everything else in the chart. So I did with you the first 4 rows on this chart. So now I want you to do the next 4 rows by yourself, and I provided the answers for you, and then you'll have a few other questions in your book so that you can continue practicing having some of this information and being able to deduce the rest of the information.